So what I want to do is just give you a review of procedure to solving material balance problems. So we've done this, we've solved material balance problems, but when we get to complicated problems, we need to have a set established procedure, otherwise we're going to get lost or we're going to make mistakes. So this procedure is outlined in the book, so it's not anything that anything that I'm necessarily coming up with, but it's outlined in the book, and the book does a great job giving some examples and so forth. But again, review is key and important, so that's what we're going to do. Number one, draw flow chart, label unknown variables, identify known data. And then I'll add choose basis if necessary. So again, if we don't have a flow chart, we don't know what we're looking for, we don't know what's known, we don't know what's unknown, then we're not going to be able to solve the problem. So key, drawing the flow chart, labeling our flow chart, and so forth. Sometimes we may be given problems where we don't have enough information to solve without choosing a basis. We may, for instance, have to choose what the inlet flow rate is, and that's fine as long as we designate what that basis is and go forth from there to solve it. The other thing I want to say is that sometimes when reading the problems, you may be unfamiliar with some of the equipment, what it does. Online is an encyclopedia of chemical engineering equipment, and I'll post a link to that. But it's a great place to go ahead and look up equipment that maybe you don't understand what the equipment is doing. A lot of the equipment is used for separations, sometimes it's used for mixing, sometimes it's used for chemical reactions, whatever. Especially the separations, if you're not sure what the equipment does for separations, it's good to get a little background on what that is. So there we have it, step one. Step two is to perform the degrees of freedom analysis. And the reason we do this, we just don't do this because it's fun and it's a mathematical exercise that, just is a pain in the neck that professors want to do. We do that because the degrees of freedom analysis helps us identify what we can solve for and where we can solve it in the problems. Especially if we have lots of units going on, we may have many different variables, and that leads to many different material balance equations. And the degrees of freedom analysis will help us identify where we can start on a problem, where we're going to do our imaginary boundary conditions, and what we're going to choose in order for our material balance equations to solve for our unknown variables. So do that. And step three is the to write out the equations and the book specifies in order you will solve. So just writing down the equations is really another key step because it lets us get a sense as to how we're going to solve this problem. Just writing down numbers, writing down numbers and solving for unknowns without having the key equations down is just asking for disaster, because you may have the equation down wrong, you may write things down wrong. It also makes it hard for the grader to follow what you're doing. Write out those equations. Before you even start plugging in numbers in, write out the equations. And then 4, solve the equations. So solve for the equations for the unknown. That's pretty straightforward. Just a lot of algebra. Sometimes if you're bigger problems, then you may have to turn to computers to help you out with that, like Excel or MATLAB or Maple or whatever computer program you're using. But yeah, solve the equations. 5, determine any remaining unknowns. So the problem may ask you for information beyond just simply flow rates. It may ask you for compositions. It may ask you for volumetric flow rates. It may ask you for yields if it's a reaction. There may be all sorts of information that the problem asks you for simply other than simply the flow rates or mass or mole fractions. And so you might have to do a little checking on that or do a little math to come up with those. But that's it. That's the procedure. And I'm convinced that if you can follow this procedure and know how to do each step properly, you can solve any material balance problem that we're going to encounter in this course. And there you have it.